Okay. What time is it? 55. Fuck it. We'll go over muscle contraction today. You know what? Step 1, Jay!
Okay, for step 1 of a muscle contraction, we have the nerve impulse reaches the neuromuscular junction. The nerve signal from the brain arrives at a neuromuscular junction, which is this, in the axon terminal of a motor neuron.
Great job, Jay! Step 2, Aldina!
So for step 2, we have the motor neuron releases the neurotransmitter acetylcholine into the synaptic gap between nerve and muscle cells.
Great job, Aldina! Now, how about step 3?
Don't worry about it, Dr. Z. I got step 3. Acetylcholine binds the muscle receptor sites in the muscle cell.
Great job! All right, who else we got? I'm picking somebody else here. Aldina.
Okay, so here we have step 4. The sodium channels in the muscle cell open. Receptors stimulate the acetylcholine, allows sodium ion channels in the muscle cell to open.
So I take it you want to know about step 5, Dr. Z?
I sure as hell do.
Well, listen to this. The sodium ions rush into the cell and cause a change in the cell charge. Here we have the inside and the outside of the cell. This is the sodium rushing into the cell. And the sodium influx into the muscle cell causes polarity change and creates an electrical current called an AP.
Joseph, you're late. You got step 6, right?
Action potential impulses from the sarcoma membrane all the way down to the muscle cell.
Pretty good. Well, that was interesting. Jay!
Okay, I got you on step 7. This is the release of calcium, which are these blue dots, into the cell. The action potential impulse causes the sarcoplasmic reticulum web to release stored calcium into the cell and around the sarcomere contraction units.
Good job, Jade. Step 8, Aldina.
Actually, Dr. Z, I want to see you do it. Can you do
All
it
right,
for us?
fuck it, I'll do one.
Okay.
All right, step 8, guys. So a calcium influx causes myosin and actin to bind, first of all. Inside sarcomeres, calcium plus ions allow myosin heads to fit onto actin filaments. So, the resting phase. Uncharged ATP cross bridges are extended. It's over there. And then actin and myosin are uncoupled. Calcium is stored in the SR. And then the excitation and coupling phase. Depolarization spreads from plasma membrane to SR. Calcium is released into the cytoplasm. Calcium increases. Calcium saturates troponin C, turning on actin. ATP cross bridge is charged. Actin and myosin are coupled. And then actomyosin ends it. All right, Aldina, now it's your turn.
Okay, Dr. Z. So we have step 9 here. So the myosin head pulls actin filaments towards the center, allowing filaments to slide past each other in opposite directions, shortening the sarcomere. And then the third phase, the contraction phase, occurs. Activated myosin ATPase splits ATP, energy swivels cross bridges, muscle shortens as actin slides over myosin, and then the force is developed. And then the recharging phase, ATP is resynthesized, actomyosin dissociates into actin and myosin, and then the myosin cross bridges can attach to another actin if an action potential nerve impulse continues and maintains.
Oh, so no one else wants to handle step 10. Okay, I got it. So step 10 is relaxation. When the action potential ends, Ca++ is reabsorbed by the sarcoplasmic reticulum. Myosin and actin return to their original position and the muscle relaxes. During the relaxation phase, Nerve impulse stops. CA is pumped back into the sarcoplasmic reticulum. CA ATP ACE pump. Tropomyosin covers up the actin site. Actin slides backward over the myosin.
All right, guys. About 18 free minutes today. Hope you didn't have class, but all right. Jay, when's best time to study?
Right now.
Right now. That's right.